Welcome to the WANdisco Fusion lesson on networking. The topics covered are the networking architecture, Java Virtual Machine Network Internals, capacity considerations, calculating requirements, replication as seen on the network, bandwidth throttling, load balancing through IHC, multi-home networks, and uni-directional networking. The network architecture is as follows. This is for an intra-cluster example here. You can see that HDFS external clients communicate with Fusion on port 8023. External REST API calls come through on port 8082. And log into the Fusion UI happens through port 8083. For example, if your Fusion is running on an edge node, you would use the fully qualified domain name of the edge node with port 8083 to get to the Fusion UI. Other key ports are the coordination port. This is the DCON, the distributed coordination engine, port 6444, the IHC server on port 7000 for content transfer. These ports are important when you're planning an implementation or a POC to give to the administrator or to the person running the project so they can coordinate and ensure that these ports are available and open before you embark on installing Fusion. It's important to ensure that the people and the team you work with have the ability to open these ports on relatively short notice before installing Fusion. JVM Network Internals. Network traffic is handled by Netty. Netty is a framework for development of Java network applications. It simplifies the network programming for TCP, UDP, socket type applications. Channel handlers daisy chain and channel pipelines. You could see in the diagram the socket channel inbound handlers interact with the application, and on the way out, the outbound handlers work with the socket channel. Each handler performs a different job. These can be SSL encoding, decoding, and byte-to-message decoders, and more. Netty can use UIO, EPOL transports. Tunings include chunk size, thread pool sizes, and TCP overrides. Network considerations for the LAN. Remember, Hadoop proxies the HDFS client calls through the Fusion server. The location of Fusion on the cluster can impact the performance significantly. An edge node should sit on a rack backbone if at all possible, and external nodes may have slower proxy times and impact the write performance. This could be a 1 to 3% overhead. Also be mindful of the impact of adding Fusion server node that has other services running on it. For example, if you install Fusion on a node that's doing scoop for ETL or running some other type of process that's consuming a lot of cycles, CPU cycles or memory cycles, this certainly can impact the performance of the Fusion server. I would recommend trying to get Fusion server on its own edge node where nothing else will be running but the Fusion server. And for NFS and object storage, it's mostly based on the disk mount for performance. That's the most important thing to remember here. The clients are usually just API calls and they're uploads, so it's not quite the same as the HDFS for object storage and NFS. Network considerations for the WAN. Determine average ingest per day and account for expected growth. Based on this number, determine what pipeline is actually needed. Latency is a limiting factor unless using some type of compression technology like Bridgeworks. WAN calculators are helpful to determine the rate of transfer possible. The URL below can help you with that calculation. Generic figures must be validated with the user's network profile. Typically, it will include this type of setup: a network minimum, 1 gig minimum between local nodes, 8 megabytes per second minimum between data centers. The network WAN, it can be calculated on the expected ingest rate and the growth rate. So for example here, the ingest rate per hour times the megabit conversion times the growth rate percentage divided by the conversion to seconds. So in this example below, a 5 gigabyte ingest per hour and a 20% expected growth rate in the first year would be with this math here: 5 times 1024 to get your megabytes, times 8 for an 8-hour day, times 1.2 for the growth rate, and divided that by 60 squared to convert to seconds, and you'll get a 13.6 megabytes per second WAN link required between data centers. SSL and KMS can impact these numbers. Jumbo frames are compatible, but consider whether your WAN can support them. Replication is seen as a network. The number of files that can be replicated in parallel is controlled by the number of executor threads that's set at the remote Fusion server or servers. The executor threads pull data from the pool of known remote IHCs in a round-robin fashion. Each file transfer creates a TCP connection from the remote Fusion server. It's on an ephemeral port to source IHC server, default port 7000. The IHC creates a connection using an ephemeral port to the local zone storage, the data node, for example, or the object store endpoint. The IHC pull requests are retried based on the retry max attempts parameter. Many small files can rapidly cycle through the ephemeral port range on a Fusion server, so it must be understood up front what your mix of workload is going to be. For example, thousands and thousands of small files can have an effect on this port range. The transfer chunk size can be increased to improve throughput for the larger files, and the kernel TCP window size settings can be increased to mitigate high latency. For the cloud, the connection from the Fusion server to the endpoint can also be critical for bottleneck tuning. And another point to note on the cloud connection is the number of hops between your Fusion server and your cloud endpoint, and that could be cloud to cloud, the cloud object storage in different clouds, or from on-prem to the cloud. The number of hops can significantly affect that replication. Bandwidth throttling. Fusion can rate limit its overall throughput of replication. It's configurable in both directions for each zone pair, and you could see in the user interface, if you go to the nodes menu, on the specific zone for that node you could set bandwidth limits, and below here you could see they can be set for outgoing and incoming traffic. The default is 0, meaning maximum capacity, and they could be set to whichever level you want to throttle the bandwidth. The important thing is, if you do this experiment first and see what effect the throttling is going to have on your replication. Multi-home NICs. All Fusion network interfaces can be configured to specific host names and IP addresses. A common setup is to put Fusion traffic, replication traffic, on dedicated replication networks. This has performance benefits. From the picture below, you could see you would be isolating the Fusion traffic away from the LAN cluster traffic here. So that can be very performant if set up correctly. Also, there are security benefits, as firewalls can be locked down to only allow Fusion ports to communicate for this type of activity. They also can be configured with either a new host name alias or overriding the DNS lookup. That would be in the etc host file for the opposite cluster fusion nodes. Unidirectional networking. By default, Fusion's communications are established in a bidirectional manner. Some customers, however, have restrictions on accepting new connections from outside their network. No inbound request accepted through firewall, for example. Private networks can also implicitly block these type of connections. A Fusion node can be set to inbound, which signifies that it should not attempt to establish any connections outbound. This also signifies to other zones to establish connections instead. So for example, port 6444, the D cone stays the same except all ephemeral ports are on the side reaching out. IHC changes significantly. IHCs no longer listen on port 7000. Instead, the inbound Fusion server listens on port 8024. IHCs establish persistent connections on this port. Induction, though, will have to be done outbound, and an administrator would probably have to have control of that. Replication can still be bidirectional. It's just the establishment of the bidirectional channel that's restricted. Here's an example of bidirectional networking. Both zones can establish connections. They're both, you could see, outbound here. And this is the typical Fusion setup where Fusion communicates with the IHC for the pool on 7000. And Fusion communicates in a bidirectional manner with each of its servers. They're both configured out of the box this way. For unidirectional networking, notice the outbound connection and the inbound connection here. These will be configured for inbound connections only. And in this case, the IHC will talk to Fusion on the other cluster with port 8024. And the Fusion nodes will communicate with each other from the other servers with inbound connections. There's no bidirectional networking occurring here. That concludes the WANdisco Fusion lesson on networking.